Hello everyone. So today we're going to be solving an Oxford University admissions question. This was part of the physics test, and I think this was one of the earlier questions just because it's relatively easier to solve. So the question itself, there's a train going at 100 meters per second in that direction, and at the same time the train passes this gun which fires a ball at 200 meters per second into the sky with angle theta from the horizon. So we have to find theta so that the ball lands in the cart, and we also have to find how long this will take. So firstly, what are some of the assumptions we're making? We're assuming that the speed of light is much greater than this, so we don't need to worry about special relativity. We're also assuming no friction. And we're assuming that the gravity is constant. So let's just go ahead and resolve for our x component of the velocity, because we want the horizontal velocity of the ball and the cart to be the same essentially, so that the ball lands in the cart. So we want v cos theta, which is our x component of velocity, to equal the speed of the cart, which is 100 meters per second. Now we know that the speed is 200 meters per second, so we know that 200 cos theta is equal to 100. So cos theta is equal to 1 over 2. Now this means that theta must be 60 degrees, because cos theta is 1 over 2. Now we have to find the time taken for the ball to go up and then down. So what we can assume is that the time the ball takes to reach the top is the same time the ball takes to reach the bottom. So first let's find the vertical component of velocity, which should be just sine. And once we have the vertical component of velocity, we have to input this into our vertical equations of motion to find the time taken. So we know that v is equal to the initial velocity plus at. Now, the acceleration is taken to be gravity. The initial velocity is taken to be vy. And we know that we reach the final velocity, which is 0. Therefore, the time taken is minus v sine theta minus gt. We take g to be negative because we define z in this direction, and gravity works downwards. So this ends up being a plus and this minus. So as a result of that, we find that the time taken to go to the top is v sine theta equals gt. Now, sine theta is just sine 60, so that's 200 for the value of v times root 3 over 2 is equal to gt. So we can cancel the 2's, and we get root 3 times 100 over g is equal to t. We take g to be approximately equal to 10 since we do not have a calculator for this question. So we get root 3 times 10 is equal to the time to go to the top. So to compute the time to go to the bottom, we just multiply this by 2, since the time to the top and the bottom is the same. So therefore we get 20 root 3 is the total time. Interestingly, another way you could have done this is, without having to multiply by 2, is to take the final velocity to be the negative of the initial velocity, because the speed going up is the same as the speed going down. So you could have done minus v naught is equal to v naught plus at. So therefore, minus 200 times root 3 over 2 is equal to 200 times root 3 over 2 plus minus g times t. So when we solve this, we find that 400 divided by 2 root 3 is equal to gt, bringing the 200 over and then getting rid of the minus signs. So once again, we cancel the 2's and we divide by 10 for g. Therefore, we get 20 root 3 is equal to t.